Hello viewers, nice to have you in this video. What we have on our board, we have indices. Indices is one of the commonest topic we have in mathematics. And today in this video, I'm going to make it easier for every one of us. If you have come across questions on indices, do you know how to solve them? Can you find solutions to problems involving indices? Alright, at the end of this video, you are going to learn a lot. If this is your first time seeing my video, subscribe to my channel and get ready to smash. Alright, now indices can also be called what? Powers or exponents. They can also be called what? Powers or what? Exponents. We simply say that it is the representation of what? Of multiplication, a shorthand, or you can say that it is the shorthand representation of what? Multiplications. If a number multiplies itself in many times, you want to represent them without writing them in full, we use what? Indices. For example, if 2 multiplied itself 6 times, if 2 multiplied itself 6 times, if you want to represent it using indices, you are going to write it as what? 2 to the power of what? 6, which implies what? 2 times 2 times 2 times 2 times 2 times 2. So how many 2's are here? There are 6. So this is indices. Now, this superscript here is called what? This is called the exponent or the power. Why this number is called the base number? So the 2 is the base number, whereas the 6 is the power. Now, under this topic, you're going to learn laws. There are laws behind this topic. Once you get to know them, you can be able to answer questions without failure. Alright, let's go through the laws of indices. Today we are going to start with the fundamental laws of indices, because if you know those fundamental laws, you can be able to get to the advanced level. Alright, now the fundamental laws we have in indices. The first one, we have what? Multiplication law. Second one, we have what? Division law. Third one, we have the power of a power. The fourth one, we have what? The zero law. The fifth one, we have what? We have the fractional indices or the fractional law. The sixth one we have is the what? Negative index law. The negative law. So these are the basic laws we have under indices. So I call them what? Laws of. Now let's proceed with them one after the other. So we are going to start with what? The multiplication law. Now, when you talk about the multiplication law, of indices, it states that when two indices are multiplying themselves, you take their base number and add their powers, provided that their base numbers are the same. Now, mathematically, this means that what? A squared times A cubed is equal to what? Now, this is the base number like I've explained earlier, why these ones are the powers, right? So you do what? You take the base number, which is what? A, then you add up the powers. You have 2 plus 3, which is A to the power of what? 5. When the two base numbers are the same, we add their powers. This is simply the multiplication law of indices. Now, if you have a question like this, where you have 3 to the power of 3 times 3 to the power of 5. Provided that 2 of them are 3, right? Good. The next step we are going to take is to what? Add the powers. So we have 3, we have 3 plus what? 5. These are the powers which you sum up to what? 3 is to the power 8. So this is multiplication law. Now the second one we have is what? We have the division law. The division law of indices. This law states that when the base numbers are the same, we do what? We subtract their powers. So if you have an indices dividing another indices, what are we going to do? Yes, I'm asking you. If you have two indices dividing themselves, what are you going to do? Alright, we have example. We have if a raised to power 5 is divided by a raised to power 2. This is equal to what? This implies what? A to the power of what? 5 minus 2, which is a to the power of what? 3. So now let's look at this example. We have this example. We have what? 5 to the power of what? 12 divided by what? 5 to the power of what? 6. Now, do you think that we are going to divide 12 by 6 to get our answer? Oh no, we are not going to divide it. Rather, we subtract. If you divide it, you are no longer following the laws of indices. So let us not deviate from these laws. So what are we going to do here right now? This implies 5 to the power of 12 minus 6, right? Which is what? 5 to the power of what? 6. Answer to. So this one is what? This is division law of indices. The next one is power of a law. The power of a law. Now, the next one is what? Power of a power. Power of a power. Now you have for power of a power, law, once there is a power multiplying an index, or indices, we do what? We open the brackets. For this power of a power law, once there is a power outside the bracket of an index or indices, we do what? We multiply them. For example, if you have 2 to the power of m, or bracket to the power of what? N. This implies 2 open bracket what? mn. This is the answer. This implies what? 2, then this m is going to multiply this n. You have mn. So we have a raised to power 2, or bracket 3. This implies what? A raised to power what? 2 times 3, which is what? A raised to power 6. So this law is power of a power law, and it is very, very simple. Now the next one we have is what? Zero law. Right from time, we all know that any value raised to power 0 is equal to 1. So any value raised to the power 0 is 1 apart from 0. Now this means that a to the power of 0 is what? 1, right? Now 100 to the power of 0 also gives us what? 1. But mind you that a to the power 0 is not equal to 0. It cannot give you 0. Rather it will give us what? 1. Another one you should consider is 0. 0 raised to the power 0 is not equal to 1. Rather, it is what? Undefined. So 0 raised to the power 0 is undefined. Another law we have here is the fractional law. So let's get straight to the fractional law. The fractional law. Under the fractional laws of indices, once the index number is a fraction, once it is in fraction, the numerator will become the power, while the denominator will become the root. In other words, we have a to the power of 2 over 3. 2 is the numerator and 3 is the denominator of the fraction. It means that the power or the exponent is already a fraction. So if you are given something like this implies what is the denominator? 3, right? So the denominator becomes the root and the numerator becomes the what? Power. So this is another way to represent this particular value that we have on the board. So if we have x to the power of 4 over 5, this implies the fifth root of x all raised to the power 4. So this is another method of what? Writing this particular value. Another law we have here is the negative indices or the negative law. Let's look at the negative law of indices. When the power of the base is a negative value, we reciprocate the base. In other words, we say we take the inverse of the base. So here we have, for example, a to the raised to the power minus 2. Now, if you look at the board, the minus 2 is a negative number, right? So whenever the power is a negative number, you have to take the inverse of the base number. So this implies what? 1 over a. So what is the power we have here? 2, you bring it down. 2. So you have 1 over a is to the power 2. Another example we have is what? 5 is to the power minus 2. This implies 1 over 5 is to the power 2, which is 1 over 25. So these laws are very, very simple. If you understood the laws that we have on our board, please type received. Alright, I'm going to proceed with the worked examples. I'm going to solve few questions on the board so that you can learn very well from those questions. Alright, let's go. Now, the first question I have here is what? The first one I have here is 16 to the power of 1 over 4. Here we are to apply the laws we have learned so far. Now this is what? Fractional indices. Now most times they will ask you to solve questions without using calculator or without the head of calculator or 4-figure table. So you have to use your head and what? Find the solution. So if you have something like this, if you don't want to waste time, in solving this particular question, what do you do? Now let's go. This 16, you are going to break it down to an index form. So that is going to be to its simplest form. Breaking it down, make sure that you break it down such that the base number is a prime number. You remember what prime numbers are, right? Those numbers that can be divided by 1 and itself, they are prime numbers, right? So have to reduce it to its simplest form such that the base number is a prime number. Now reducing this 16, we have what? 2 to the power of what? 4. Bracket 1 over 4. Now what happens here? This 4 cancels this 4, and you are left with what? 2 raised to the power 1, which is equal to 2. Many people might ask, how do we get this 2 raised to the power 4? It is very, very simple. For you to reduce 16 to its index form, you have to divide it with the simplest number, which is what? 2. 16 can be divided by 2, right? Very good. So you have to divide it by 2. Now, after the division, how many times do you divide it? It is 4. The hook of this particular thing. Now, let me make it snappy for you guys. This is 16, and 2 divided 16, you have 8. 2 divided 8, you have 4. 2 divided 4, you have 2. 2 divided 7, you have 1. How many 2 do you have here? We have 4, right? How many 2 are here? There are 4. So you have 2 raised to the power 4. This is the index form of 16. So this is what we are going to do there. Okay, in the subsequent ones we are going to solve, there is no room for asking much questions. You have learned how to find your index form. Now let's continue. The second one we have 27 to the power of minus 2 over 3. 27 to the power of minus 2 over 3. Now the same thing is applied. Let's break it down. This implies what? 3 to the power of what? 3. This will give you this, right? Bracket minus 2 over 3. What happens? This will cancel this. Now you have what? 3 open brackets what? Minus 2. The bracket is already out. So, taking this as a case study, we have what? 1 over 3 to the power of 2. This is a negative indices. So, you have to take the inverse of the base number. Now, 3 raised to the power 2 is what? 9. So, we have what? 1 over 9. That's our answer. Now let's look at this. Question number 3. We have a to the power of 3 over 2 times a to the power of minus 1 over 2 all over a to the power of 5 over 4. Now in this particular example, laws are being combined here. Different laws are combined and we are going to solve them. We have multiplication, we also have division. Now let's not forget that we have the fractional law and also the negative part. So let's simplify it. Now remember, their base numbers are the same thing. We are going to follow the trend. Now we have a to the power of 3 over 2 times a to the power of minus 1 over 2 divided by this one, a to the power of 5 over 4. This is what I'm expecting you to do. Now at this juncture, let us bring them together because they are in the same base. This implies a, now you have 3 over 2, because it's multiplication you have plus, bracket minus 1 over 2, now you have division, minus 5 over 4. Remember, whenever you are solving this, it's just one base that you're going to take out. Just one a, the rest of them, we don't need them now. Alright. This implies what? Let's try and open this bracket we have here. A to the power of 3 over 2 plus minus is minus 1 over 2 minus 5 over 4. So the power is a fraction, and we are trying to simplify that fraction. So what do you think you are going to do here? You are going to apply the knowledge of what? LCM. So solving a fraction that involves addition and subtraction, we use what? LCM. Now here, this is exactly what you are expected to do. So A to the power of what? What is the LCM of this? The LCM is what? 4. 4 divided by 2, we have 2. 2 times 3, 6 minus 4 divided by 2, we have what? 2. 2 times 1, 2 minus 4 divided by 1. 1 times 5 is 5. Now this implies A, 6 minus 2, 4. 4 minus 5 is minus 1. So we have minus 1 over 4. Therefore, our answer is A minus 1 over 4. This is the answer to this very question. Now the next one we have here is what? Equations involving indices. Equations involving indices. Take this as a case study. Have 2 to the power of what? X plus 1 equal to 8 to the power of what? X minus 2. If you have an equation where there is indices, how do you solve it? It is very, very simple to solve. Now, it is an equation because of the equality sign. Very good. So here, you have to balance the equation. Make sure that the equation, they are what? They are balanced. If you balance the left hand side and the right hand side, then you continue solving. How do you balance it? Make sure the base here is equal to the base here. So the base in the left hand side should be equal to the base in the right hand side. So we already have 2 here, we are going to break it down. So this implies 2 to the power of what? X plus 1 equals, breaking this down, we have 2 to the power of what? 3 bracket x minus 2. At this juncture, the bases are the same, we cancel them out. 2 cancel 2. You equate the powers, we have x plus 1 equals 3 open bracket x minus 2 bracket close. Now opening this bracket further, we have x plus 1 equals what? 3 times x, 3x minus what? 3 times 2. So we have to collect like terms. Collecting like terms, we have, let's collect these like terms, right? We have 1 plus 6, this will come over here, equals to 3x minus x. 3x minus x, we have what? 2x equal to 1 plus 6, we have what? 7. Dividing both sides by the coefficient of x, which is 2, we have that x equal to what? 7 over 2. Or, changing it to a mixed fraction, we have 3 whole number, 1 over 2. This is the answer for this particular question. Alright, we're going to be rounding up with these 2 questions we have here. Now, after this question, I'm going to give you the one to solve on yourself and let us know what you have come about with it. Alright, here we are going to continue with number 5, the solution. For these 2 remaining questions we have here. For number 5, we have 2 raised to the power bracket 2x plus 1 times 4 raised to the power bracket x minus 3 equals 32. Now let's balance the equation. This implies, first we balance the equations, right? 2 raised to the power 2x plus 1 times 2 to the power of 2 bracket x minus 3 equals to, you break it down to 2 to the power of what? 5. This implies 2 raised to the power Okay, now here we have to cancel. We don't have to cancel this. I know that's what you want to do, right? No. If you cancel this, you're going to arrive at the wrong answer. So what you're going to do now is to apply the laws of indices in the left-hand side before you can be able to cancel. Now this means that you have 2 to the bracket of what? 2x plus 1 plus 2 brackets x minus 3 equals to 2 bracket 2 raised to the power 5. Here 2 then cancels 2. This implies 2x plus 1 plus, you open the bracket, 2x minus 6 equals 5. So this implies what? You have to collect the like sign. So you have 2x plus 2x equals to 5 plus 6 minus 1. 2x plus 2x gives us 4x. 5 plus 6 is 11, minus 1 is 10. Divide both sides by 4. By 4. X is equal to, this cancels, 2 we cancel them, 5 over 2. Or 2 over 1 over 2. What is the value of x in decimal? If you know it, add it to the comments. Alright, now let's go to the last question we have here. The last question we have is question number C. So we have A raised to power 2, B minus 3, C 3 over 4 divided by A minus 1, B 4, C 5 equal to A, P, B, Q, and C, R. Now, the main question for number 6 is find the value of P plus 2Q. So we have find what? P plus what? 2Q. This is what you are going to solve after simplifying it. First, you are going to simplify these particular values we have here to get P, Q, and R before we find this. This is typical hit-semi equation, SSCE, or posit-semi equations under indices. So do not neglect this particular solution. Let's solve. You have, this implies applying the laws of indices, you have division, right? So you have A, what are you going to do to the powers? You're going to subtract themselves. You have A, 2 minus 1. For B, we have minus 3 minus 4. For C, we have 3 over 4 minus 5 equal to A, P, Q, C. Now let's focus on the left-hand side because we are trying to simplify. I have A to the power of what? 2 minus is plus, right? So you have 2 plus 1, which is what? 3. So you have A to the power of 3. Now B, you have minus 3 minus 4, which is minus 7. C, you are going to apply what? The LCM method to find C. So you have the LCM is what? 4. Balancing it and making it a fraction. 4 cancels itself. 1 times 3, 3 minus 1 cancels 4, 4 times 5, 2. Now, equals A to the power of P, A to the power of Q, C to the power of R. So here we have, this implies A to the power of 3, A to the power of minus 7, C to the power of 3 minus 20 is minus 17 over 4. A, P, Q, and C. Now, at this juncture, we can be able to determine what our A, P is, B, Q, and what? R. Now at this juncture, we can be able to determine P, Q, and R. So from here, P is equal to what? 3, right? Q equals -7 and R equals -17 over 4. But the main thing we are solving for is what? P plus 2Q. So we have, this implies P plus 2Q equals to what? 3 plus 2 bracket minus 7. Because P is 3 and Q is what? -7. Now, equals 3. If you open the bracket, you have -14. Equal to what? Answer. Therefore, P plus 2Q is, this is the answer for question number 6. I'm going to give you a question to solve and tell us the answer in the comments. We have 5 raised to the power x times 25 raised to the power x plus 1 equals more than 25 to the power of what? 2x minus 3. So, and let us know your answer in the comments. You can as well show your working to prove that you understood this particular topic. Now, many students out there needs this particular tutorial. Do well to share this video with them, and don't forget to subscribe to our channel for more tutorials on science subjects. You can as well tell us the topic you would like us to discuss in the comment section and wait for the main video. As you keep learning with us, get ready to smash. I still remain Tutor Josie.